This standard is ARCH.HSA.SSE.B.4.8.5b. The learning target is I can derive the formula for a sum of a finite geometric series and use the formula to solve problems. A series is just a sum, which is adding numbers together. A common ratio is the number being multiplied by each term in a geometric series. So let's look at that example. Example, 2 times 3 equals 6. If we use the number 6 here in our next term and multiply it by 3, we get 18. If we use 18 in our next term and multiply it by 3, we get 54. And if we use 54 and multiply by 3, we get 162. So you can see each time we're multiplying by 3. But what would we do if we were given a sequence of numbers, such as 6, 18, 54, and we didn't know the common ratio? To find the common ratio, you have to take a number and divide it by the previous number. So 18 divided by 6 equals 3. That's how you find the common ratio. So let's take another example. A sequence of numbers is numbers separated by a comma. They're not being added together yet. That would make it a series. So the sequence here, step 1, we want to find the common ratio. The common ratio would be 8 divided by -2, which is -4. So, to find the common ratio, how to? You divide a number by the previous number. Now we want the sum of this sequence. The series is the sum of this sequence. The sum of a number of numbers, which would be n, equals a times 1 minus r raised to the n divided by 1 minus r. Let me repeat that. S sub n equals a times the quantity 1 minus r raised to the n divided by 1 minus r. So for example, if we wanted the sum of these 3 numbers, the first thing we do is a is the first number, so we put a -2 times the quantity 1 minus, and we found the common ratio, -4, raised to the number of terms we're adding 3 terms we decided, divided by 1 minus the common ratio, which equals -2 times 1 minus -4 to the third is -64, divided by 1 minus a -4 is the same thing as 1 plus 4. Here we're also changing 1 minus a -64 is 65. So we have equals, this whole thing equals -2 times 65 over 5, which equals -26. And what we're saying then is the sum of these 3 digits is -26. You can use your calculator, and you could have found it very quickly by entering -2 plus 8 equals -32. But what if you had a million digits that you wanted to add together? You wouldn't sit here and add them one by one. So this formula allows you to do that very quickly. However, our goal today is to explain or derive the formula that allows us to to use the formula. So this symbol is a Greek alphabet called sigma, and it is Greek for sum. To derive the formula S sub n, the sum from the first term to the nth term of the first digit A of the first term times the quantity 1 minus r to the n divided by 1 minus r is really the same formula here, written more simplified. However, because you need to be aware of this representation, again, S sub n is the sum of however many terms. I means starting with the first term. N means finishing with this term. A is the value of the first term. R is the common ratio, which we found by dividing a term by the previous term. Step 1. This is a sequence of numbers being added, so it's a series. So the sum of a certain number of numbers equals, so you have A, and then that's added to A times your common ratio, plus A times your common ratio, etc. All the way to the final number, which you have to take it to the n minus 1, which excludes this number because it's not being multiplied by a ratio. Step 2, you multiply the series by r. So S sub n gets multiplied by r, and then on the other side of the equation, each one of these terms gets multiplied by r. So now you don't just have a by itself, you have a times r, and then ar becomes ar squared, etc. Step 3, you subtract the bottom equation from the top equation. So we had created a new equation by just multiplying each side by r. Now we're going to subtract this from this. So S sub n minus S sub n times r. So that side is being subtracted. And then this minus this. So that whole top line minus this. So now we're going to rewrite it horizontally so that we have S sub n minus S sub n times r equals, now each one of these, a times r minus a times r, would eliminate it. And you keep going, eliminating, until all you have left is the original a. And then at the end of the second one, you don't have an n minus 1 because it doesn't exist. So you still have a times r to the n power. So now we're going to factor an S sub n out of these two pieces. So S sub n times 1 is S sub n, and S sub n times a negative r is just rewritten because we factored this out of both pieces, both terms. On this side, we're going to factor out an a from both terms. So we put the a out in front. A times 1 is still a times r to the n is still minus a times r to the n. Now we're going to divide 1 minus r on both sides because we want to isolate the S sub n. This should be a very small n below. It's not being multiplied. It's a representation of how many terms you have to sum. So S sub n times 1 minus r divided by 1 minus r, so that we can eliminate it. We multiply this side. We divide this side by 1 minus r. And finally we're left, this cancels here. We're left with S sub n is equal to A times the quantity, 1 minus r raised to the n divided by 1 minus r. So if you look at our previous page, that is the formula that we used to find the sum of a sequence of numbers, a series. And that concludes this lesson.